And we have two parts in mobile IP. This part is IPv4. The next lecture would be IPv6. Okay, and a lot more is being done in IPv6. In this part, we will talk about the terminology, registration, security issues, reverse tunneling, and then when the home network itself has a dynamic IP address and dynamic home agent. So basically, in mobile IP, you have a home network such as your network here at WashU is your home network, and you go to some other university and you are able to access WashU network, that would be your home network. So dynamic home agent assignments, and the network mobility. What happens if your whole network moves up, moves out, or moves around, and then VPN. So first of all, what does mobile IP allow you to do? With mobile IP, if it was deployed, unfortunately not that much deployed, so you haven't seen this thing, but this has been going on for quite some time, mobile IP work. And we hope that soon it will become a reality. But if it was deployed, then you could take your notebook to any location, and then if, I mean, that was another if, because TCP actually has a very short timer, so you couldn't do that. But if the TCP didn't time out, then you could take it, you could continue your connection and from another IP address, and TCP will not be knowing that you have moved, your IP address has changed. That way, you could have continuous access to your home resources. Home basically means your network at your primary network, which doesn't have to be really your home. It could be your office. So basically, we will use two names here, home network and foreign networks. Home network is the network that you generally use every day, and foreign network is what you are visiting for a short time. Right? So the home network means the networks that you normally use. So you can continue to access your home resources, and that includes, for example, printers. And you can find the nearby routers and connect. Basically, what you would do is when you're in the foreign network, you would find out a nearby IP router in the foreign network, and you will connect with automatically. Because your computer understands mobile IP and the router understands mobile IP, they will let you connect. Your IP messages are delivered to your new location, and then your mobility aware router and mobile unit need new software. So basically, two things need new software. First, your computer needs new software to understand mobile IP, and the router that is giving you access to this foreign network, they need to know about mobile IP. Intermediate routers don't know anything. But you need another router at home that understands mobile IP. So you need three things to know new stuff, new mobile IP. One is your home network router, your foreign network router, and your computer. Your correspondent don't need to know anything about mobile IP. They would just send you a message, they will just do FTP, they will just do HTTP, as if they were doing it to original network. Alright? And so other routers. And no new IP address format, and it is secure. So those are the features of mobile IP. Basically, it lets you offer your services or communication, you can do communication as if you were local, if you're at home while you're, so I mean, that includes the website. I mean, if you have a website which is at your home network, and on your laptop, you could take it with you to every place and people will be able to access it as long as you're online. If you're not online, obviously they can't access it. So this is very similar to what we do today without the routers. And so let's consider a case where Mr. Smith goes to Washington. All right. So if Mr. Smith goes to Washington and somebody wants to reach him, and this is Mr. Taylor, and says, "Can I speak to Mr. Smith?" And so who answers the phone? Obviously, Mr. Smith doesn't answer the phone. He has an assistant, and the assistant says, "Hello, Mr. Taylor," and then he says, "Can you connect me with Mr. Smith?" And she says, "Yes." What she does is, it could be he as well, what he or she does is, she contacts the hotel where Mr. Smith is, and says, can you connect me to Mr. Smith in room XYZ? And then Mr. Tiller doesn't even know that he's talking to Mr. Smith in a hotel room, right? This is what we do today, is that the assistants provide you connectivity when you're out. Now actually, more than talking to a hotel operator, maybe she will dial a cell phone number and same thing will happen. They would not know that a cell phone number has been dialed and you are connected. But what you need is two agents. You need a home agent which answers the regular number, and you need an agent, a foreign agent, which basically connects you in the foreign location. That's what mobile IP does. It needs two routers. The one router at home, which is called a home agent, and one router at the foreign network, which is called a foreign agent. And the node that is moving is called MN, mobile node. So the mobile node was here in the home network. It moves to a foreign network. So that is the mobile node. This is the correspondent node which is trying to reach. So CN calls the mobile node. The call is intercepted. Now here's the interesting word. The call is intercepted by the mobile agent because the correspondent node was not trying to reach the mobile agent, it was trying to reach the mobile node. But the call is intercepted by the home agent and forwarded to the foreign agent and forwarded from there to the mobile node. So all this arrangement has been done before any correspondent call. The mobile node told the home agent, look, I am in this hotel room number such and such, right? So it registers with the foreign agent and registers with the home agent. All that has been done beforehand. But the correspondent node, when it calls, the question is how do you catch, how do you intercept an IP communication? Anybody can think about how to intercept an IP communication if, assuming that both the home agent and the mobile node are on a single Ethernet, or they are on a single Ethernet. Right, so the way the communication happens is all the packets from anywhere in the world, they come to a router on that Ethernet. That router then broadcasts it, actually it sends, not broadcast, it sends it on the Ethernet as a MAC packet, Ethernet packet, which is addressed to the MAC address of the mobile node, right? And the way we know what is the MAC address is we send a ARP packet. Remember the ARP address resolution protocol? We ask everybody who has the IP address of 122.34 and whatever it is, and somebody says, it is mine and here is my MAC address, then we know that this is their MAC address of the IP address. But the router could answer that. This home agent could answer that ARP message. So all the local traffic as well as the foreign traffic would go to the home agent by manipulating the ARP. And then once it goes to the home agent, then home agent can take care of it, the rest of it. Okay. So now let's see the terms. So we know what is the mobile node, we know what is the foreign agent, we know what is the home agent, we know what is the care of address. Now, what is the care of address? So basically, what they're going to do is they're going to develop a tunnel. They're going to develop a tunnel from the home agent all the way to some place, and that could go end at the foreign agent or could end at the mobile node itself. Tunnel means nobody along the way basically can see those inside packets, so we just put a wrapper around the packets and send them to some address from here. That address could be foreign agent address if it is trustable agent. If it is not trustable agent, trustable means in the sense of being able to see the packets, then we will just address it to this address here, and it will be the packet will be opened here in the mobile node. So those are the care of address. Care of address could be foreign agent or could be mobile node. That could be anything else as well, but so that's the end of it. Okay. Then we have correspondent node, and then we have the home address, which is the mobile's permanent IP address. So I think this is a repeat. That's the home address. We know IP access address, local IP address of the mobile on the foreign network. So that was, when you get to the foreign network, there are several addresses. There is a foreign agent address, there is a home IP access address, and there is a care of address. Alright, so care of address could be either the IP access address or the foreign agent address. Mobility agent. So either one of those two agents, home agent or foreign agent, are part of a category of agents called mobility agents. So, they can, if you have a mobility agent software, you can act as a home agent or a foreign agent. Now, agent sends out advertisements. So every so often, the home agent says, look, I am a home agent. If any guys, if you want to move out, let me know. Foreign agent says, well, I am a foreign agent. Actually, foreign agent sends out the advertisement more than the home agent, because home agent you already know. I mean, you don't need to find out your assistant every day. But when you go to a foreign network, you don't know whether there is a router here which understands mobile IP. So there are two ways. One is that the foreign agent broadcasts every so often, every second or minute or something like that, saying, I have the available services. In case you want to connect to the internet, obviously they will ask your credit card next, but right now they are going to advertise anyway, tell you that we have these services. And then our other way is that you send out a message to the world on the Ethernet or on the wireless saying that, is there any home agent here or any foreign agent here? Mobile node wants to discover the foreign agent either by listening to the advertisement or by a query.
So what does it mean?
Yeah, once you have found the foreign agent, then the next part takes place. That's the next part. Then you can send. See, first of all, if you are, let's say you are in Germany, until you get to the internet connection, you can't talk to your router at WashU. Right? So first step is to find a foreign agent that lets you connect. Right? Once they let you connect, then you send messages to anywhere you want to send, and first thing you will do is to tell your assistant that, look, I have arrived at the hotel and I'm fine. Here is my room number. Right? So then you register with the home agent. First you have to register with the foreign agent. Just registering with the hotel. Until you register with the hotel, you don't have an address. Alright, so correspondent now. So we have an agent advertisement, we have correspondent node, we have foreign networks, we have gratuitous ARP. That ARP is basically the response which is sent by the home agent so that other people will send all the packets to its MAC address and not to the old MAC address. So it just advertises, look, my IP address is such and such, and my MAC address is such and such. So that's actually is the gratuitous ARP message, which is basically updates everybody's cache. Everybody sends the packet to this new address for that old IP address. So then we have mobility binding. That is the channel which goes between the home agent and the care of address, home address and the care of address. A tunnel is the path followed by the encapsulated packet. So by the way, what is a tunnel? And actually I think in the next few slides I might define what is a tunnel, but basically tunnel is another name for encapsulation. You can take any packet, put another envelope around it and put the new address. So you take the old packet which was addressed to your home address, put it into another box, put new address in Germany and send it off via FedEx. So that's your encapsulation, that is your tunnel, right? In case of IP, it will be another IP header on the top of the previous IP header and then sent off to the new address. Mobile router, a router that moves. Mobile host, a host that moves. A mobile node is either a host or router, so node could be either one. A network which whole thing moves, for example, a network on a plane. If you had a local area network on a plane, it will be moving from city to city every hour, every minute, or every day as it is moving. So that is a mobile network. Mobile network node is a node in a mobile network. So somebody sitting inside the plane is a mobile network node. Roaming has to do with more with the financial arrangement. So if you have an arrangement with the foreign network, then they let you allow. So that is called roaming. So given connectivity foreign network based upon a formal agreement between the foreign and the home network service providers. So if you had here a DSL, let's say from AT&T, and you went to some foreign country, and they let you connect to their DSL or dial-up network or whatever it is, then there must be some roaming arrangement between those two. Okay. We have already talked about make before break. So this is similar to handover, but we don't call it handover here. This is, so basically you will have make before break and break before make, where you disconnect the previous connection, and then there's a handover delay, which is the time between the break and the make, and the smooth handover. Basically, a smooth handover is when both the routers try to attempt to minimize the packet loss, and the delay may not be critical in that case because they will buffer the packets. Fast handover, where they try to minimize the delay, and in spite of that effort, packets may be lost because they don't buffer it. Seamless handover is that you don't even feel that you have moved over, and that means no change in quality, security, or capability of the service. Okay, so there is obviously this, all seamless over would be more of a make before break kind. Diversity means that being able to connect to more than one signal at the same time. So you could have two Ethernet ports in your computer, or you could have one Ethernet port and a Wi-Fi port, or you could have two Wi-Fi ports, so that way you can talk to two networks at the same time. Microdiversity is the two signals between the same subscriber and the base station. Now we are getting a little bit into, yeah, right, okay. And then macrodiversity is two signals from different base stations. So microdiversity is basically you are not changing your base station. In macrodiversity, you are changing the base station. IP diversity, you are changing to routers. So basically, you are talking to two routers. So basically, it is quite possible that you are connected to two base stations. Both of them are connected to one router. If they are both connected to one router, that means both of them are in the same subnet. So you don't have to change your IP address. So it depends upon where the connection merging takes place, whether it is at the base station or whether it is at the router. If it is at the router, that would be IP. No, if it is at the router, that would be macro diversity. But if it is between different routers, then there is IP diversity. Micro mobility is moving on the same network, and macro mobility would be moving between different networks. So, and that's where you need the IP. If you have macro mobility, then only you need to worry about mobile IP. Because if you're just moving between the base stations without changing subnet, then mobile IP can't do much for you. You're not even changing the address. So there is a slight fine point here that we have three diversities only, but two mobilities only. And so while macro diversity relates to base station, macro mobility relates to IPs.